Section 3.5, implicit differentiation. I'd like to just pretty much highlight this section. There's a lot going on here, a lot of explanation. So I'm going to try to make it as simple as possible. What we have here is we have some special function notation. So basically, we have two or more independent variables. So rather than just an f of x, we have an f of xy. And we can differentiate with respect to one of those variables. So it's called implicit when we can't just write our function in regards to one variable, such as f of x equals 2 minus 3x squared. We know that that can mean y equals 2 minus 3x squared. And a lot of functions aren't that easy to write that way. So explicitly, it's stated y equals 2 minus 3x squared. But implicit, we put it all on one side. And I'm just going to show you the two different ways, or compare the two different ways. So explicitly, if we take our f of x equals 2 minus 3x squared, where we're in regards to one variable, and we take the derivative, we get negative 6x. Implicitly, we have to look at, in regards to one variable, if I take implicitly, this would be y prime, then we have 6x plus y prime plus 0 equals 0. And then we solve for y prime. Y prime equals negative 6x. And you can see that they are the same. So if you want to read up on the why we do this, you can certainly read your notes, the textbook, if you want to get the ifs, ands, and buts. I just want to get through the process. So let me take another example, equation of a circle. Find y prime. Well, y prime is going to equal the derivative of x squared, which is 2x, plus the derivative of y squared. Now, y squared is 2y, but then we still have a y prime. Derivative of negative 25 is 0 and 0. And then you solve for y prime. So the first thing we need to do is move the 2x. And then just like any other problem, we're going to divide by 2y. And we're going to simplify. Find the slope of the graph at x equals 0. Well, remember, first derivative is our slope. First derivative is our slope. But you need to find the corresponding y value for that x. So you must still find the corresponding y. So my equation would be, let's find our y, would be 3 squared plus y squared minus 25 equals 0. 3 squared is 9, so I get y squared minus 16. Y squared equals 16. Remember, when you take the square root, you get two values. So then the slope of the graph, we have, oops, sorry about that. We have two values. We have it coordinates 3, 4, 3, and -4. So my slope be -3/4, and over here it'll be +3/4. Substituting in to our slope. Let me, sorry about that, let me just write that over here. So our slope would equal -x over y. Okay, and this goes into some further exploration, looking at graph the circle, again, at x² + y². -25 is graph of the circle. So let's try the match problem. Let me give you some insight as you're working through it. Again, remember that derivative of y² is going to be 2y y prime. And maybe I shouldn't write that like that. Maybe a dy dx of y². And go ahead and try that. And then you're going to continue, once you find the derivative, find your corresponding y values, and then use x and those y's for the coordinates to find your slope. How did you do? Hopefully you were able to get that. Okay, let's look at another example. Find the equation of the tangent line to the graph at the point where x = 1. This is probably one of the more extensive problems. So the first thing we need to do is find our derivative. So the derivative of y is y prime. And then we need to use our product rule for this portion here. Okay, so it's first, and let's put that in parentheses. First times the derivative of the second plus the second times the derivative of the first, which is 1. And then we can continue with the rest. I'm just going to rewrite that. Then we're going to group together or keep together our y primes. So I'm going to leave that out here. We factor out that y prime. and then we divide. Find our corresponding y values where x is 1. So I'm going to take that up here. We have y minus 1 times y squared plus 1 squared plus 1. So we're going to get 1 squared plus 1 is 2. So we're going to get negative y squared plus y plus 2 equals 0. Multiply through by a negative and factor. So plus, let me erase that. So you get y equals 2 and negative 1. So our two coordinates are, I keep wanting to write down x, I don't know why. 1 and with 2, and we have 1 with negative 1. What's our slope when it's 1, 2? We get 2 squared minus 2 times 1 over 1 minus 2 times 1 times 2. So 4 minus 2 is 2, and 1 minus 4 is negative 3. And then our other slope, we get negative 1 squared minus 2 times 1. 1 minus 2 times 1 times negative 1. So we get 1 minus 2 is negative 1, and 1 plus 2 is 3. Writing your equations then, taking the first one, y minus 2 equals negative 2/3 x minus 1. Add the 2, which is 6/3. And you do the same thing for the other coordinate. We need to subtract 1, which is subtracting 3/3. A little challenging. So try the match problem number 2. It's in my scribble there. And see what you can come up with. I'll put some questions. I'll put a question or two. I know this is a challenge, and I'm hoping that you will do some of the practice, maybe in the textbook, looking at the learning worksheets, to get some more practice with this implicit differentiation. I am not doing the bottom portion with the multiple variables. I think just staying in the context of x and y for now is good. I'll post the answers. Good luck. Okay, this concludes